This is internal design discussion about future Wolfram language features. This is a fairly exploratory discussion about something we are just having to confront. It has to do with timed parameterized objects. So let's talk about the particular thing we've run into. So we have this way of representing flight data, that is, data about airplanes flying over the US, etc. And what happens is we'll have a geo path. Well, the question is how to represent a plane flying on a path. So, for example, when we have a geo position, let's see, if I ask for ISS, right, and I say, what is the geo position of the ISS? Somewhat bizarrely, and I'm not sure this is quite right, that geo position will be given, hopefully, as a 4-element geo position, where that is the lat long altitude in meters, presumably, and time as an absolute time specification. Is that right?
Yes, in GMT zone.
In the GMT time zone.
Exactly.
And okay, and that isn't a data object because, I mean, what would happen if I put a data object in there? Oops, as a
it will convert it.
Okay, so it knows. So if I, for example, if I put in now here, what I will get out. Oh, okay, fine. Okay. So its canonical form has an absolute time there. Okay. So the thing we now talked about is a geo path. Now a geo path normally would be a list of geopoints. But the issue is, how do we also represent essentially the alternative? Well, so I don't understand why we can't just do a geopath with geopositions that have time markers in them. Why doesn't that represent? I mean, isn't that
because we have additional information that we want to attach to each point, like velocity, direction vectors, and such stuff.
I see. So in a sense, this is a decorated geoposition at some level.
Yes, but it's not a. It's more like a field now rather than a position.
Well, except that it's a field where we only have data about specific points. By the way, did Roger join us?
Not yet. He's wrapping something. We'll be with us in just a little bit.
Okay.
So GeoPath is the geo equivalent of line. So it's a primitive, and its main purpose is graphical.
Okay. So what do you have? What would you consider to be? I mean, a field. How do we represent a field right now? It's essentially an interpolating function of some kind.
Exactly. Yes. So I think for this purpose, perhaps an object called geotrajectory or something like that, which is trained to eat times and return the information it has. But it's some sort of field living on a line rather than a field that lives on any dimension.
Okay, so let's go mathy here. So, I mean, are we basically talking fiber bundles or something here? Is there a base space and a life inside the fiber type thing?
Almost. It's like an embedding. We are embedding a line on 3-dimensional space.
Yeah, but I understand. But the line is one thing, but we also have other attributes. Okay, so the question is the fuel usage of the plane, right? Which is something which is not part of any aspect of the line. Is that something that we want to be able to attach to? So in other words, look, what we have right now is a time series. But what you're also saying is that there is, in a sense, a geotrajectory. Maybe there's a geotrajectory series, or maybe there isn't. Maybe all it is a time series in which the positions are geopoints.
Yes, that's true. Then we enter the discussion of how do we interpolate intermediate geopositions.
Quite. And I mean, there's some purposes for which, okay, so there's a difference between a and this is relevant to spatial statistics and so on, there's a difference. There's a difference between a point cloud that doesn't have the, derivative and vector information and, okay, so let's imagine that we've got a wind field, right, which is measured at discrete points, but where we imagine that there is an overall vector field that exists.
Right.
I mean, again, we're going to have, so we don't have a good representation. How would we represent the wind field right now? Can we interpolate the vector field? We can, can't we?
No, we cannot. We would just, it's like the result of geo-elevation data. We would give an array of values and you're responsible for dealing with those values.
I see. So one example of this would be geo-elevation data. If you ask what is the geo-elevation at so if you ask for a very specific point,
yeah,
right, it will interpolate. Is that correct?
Exactly.
Okay. So it's its own business to interpolate. So if I say wind vector data and I say here, it will hopefully interpolate. Interesting.
Yes. So the question is, how do we represent many of these? For example, in geo-elevation data, you can give a region and then
you get a quantity array.
Exactly. Or with a third argument of geoposition, you get a geoposition with positions containing a third argument. But of course, that's very particular of elevations because they fit very nicely in geoposition.
Sorry, if you gave geo-elevation data in the second argument.
The second argument is the type of elevation. So in this case, it would be automatic or orthometric. And then the third argument is the representation of it. When you say geoposition, I think it works both with a string, and then you get the geoposition with the elevation there in meters. Geoposition always takes numbers.
Okay, so what you're saying is, okay, so what would happen with the wind in this case? If I say wind vector data.
Yes, that's what I'm saying. We don't have a good representation for it yet, because the special thing of the elevation is that they have a natural third argument in geoposition, but there is no natural argument there for a vector field. So we do need some sort of geo interpolating function object or something like that. I have discussed this with Roger at some point.
Is Roger here now?
Yeah.
Mm-hmm.
I mean, that's an interesting idea, a geo interpolation that could operate on any where, I mean, it's sort of like time series, though. I mean, it's an analog of time series, isn't it? I mean, time series will give you something where you give it a bunch of discrete points where it's
no.
time.
I think that Jose has something in mind that behaves like, well, it's true that time series does interpolate, but time series can operate through on things. Are you going to have this behave like a function or like time series? Because time series makes approximations. Otherwise, you wouldn't have all these closure operations. Do you see what I'm saying?
Give me an example.
Okay, if you have a time series and you apply the function sine on that, in principle, that should apply to every single point in time, but it doesn't. It only applies to the points that you have given and then interpolates between those. That's obviously,
I see what you're saying. So
it's obviously wrong. False, but it's good enough for the kinds of operations that you do on time series.
Well, wait a second. So you're saying the application of a function commutes with, see, this is complicated because let's say I did a moving average on the time series, okay? And it's an irregularly spaced time series. And, or let's say I've got some kind of window where I'm combining points in the time series, but it's irregularly spaced. That operation does not necessarily commute with the, with the time series interpolation, if I'm making sense. So that your sine example, taking the sine of the value commutes with doing the interpolation, doesn't it?
No. I mean, so if you have, because let's say that you use piecewise linear interpolation.
Yep.
Okay. So that means that you have a straight line, between two time points.
Yeah. Okay.
Okay. If you map those corner points open and you draw a new straight line. That's not what would happen if you mapped every point in between.
Right.
With sine.
So what are you saying? You're saying what we're doing in time series is there are certain closure properties that you can establish based on what we're doing. Is that true, or is that not?
It's all sort of a level of model that we operate on there. And we decided that this is an adequate model. It's still way better than the raw data values.
Yes, I understand. Okay, so the analog of that for geointerpolation is what's happening in geoelevation here is we are asking for a very specific point, and it is doing some kind of interpolation, I don't even know what, to find that geoelevation. What kind of interpolation is it doing?
It's quite simple. It's something linear with nearest neighbors.
Okay.
I think that the advantage of having geointerpolation is we can include those things that people are used to in geo, like nearest neighbors and kriging, and other sort of common and useful things there.
So then, what this would look like is like in time series.
If it's called interpolation, it shouldn't be called that. Then it should be something else, right?
What do you mean?
Interpolation produces an interpolating function which doesn't have this property that it that you can combine them. It will do the interpolation for you just fine, but you can't add them together.
I see. Time series is a I see what you're saying. I mean, time series, you can add to time series and it will just work.
Yeah.
I mean, this is really more like geo field, but that's a horrifying name.
I mean, from spatial statistics, I mean, that's what Jose wanted wasn't, to support the whole set of things we do for time series for geo. That will be a tall order for anybody to do. We're building something, and we will build something when we come to fields. Right now, we're working on stochastic geometry or points, where we need spatial data, just as we have temporal data, because otherwise you can't even operate on them.
Right. How is this relating to the time series and backtesting stuff that is?
Well, it's not related to that. That's another feature for time series. There's no backtesting for geofields, I think, yet.
Let's think about that for a second. I mean, for fields in general.
Oh, come on, Stephen. Yes, you can invent something, but I think that we have Jose's point is really valid. I think that there should be, but the question is what level of design. I think that can be something that behaves as a very user-friendly interpolating function that will have a different set of, and it actually shouldn't even be called interpolation because it doesn't do interpolation. Any of these things that are nearest, kriging and so on, do not do interpolation, actually. They do approximation.
What is an analogous thing? I mean, we have functions like piecewise that sort of give you values based on whatever. We have time series. What else do we have that's like that?
Those are very different creatures.
They are very different creatures, but I mean, they are...
Interpolation, B-spline function.
Yeah, but those are all functions, as opposed to something like time series, which, I mean, time series, if I'm not mistaken, has... So if I do a sub-value of time series, do I get what I think I'm going to get?
Yes.
Okay. So it does act as a function at that level.
Mm-hmm.
But it also has the feature that if I just say time series squared, for example, then, and now I do that. So this will be to your point about how...
Yes.
Okay.
It would be very nice if we can do that with the geo object, and then we feed geo positions, and we get back.
I mean, you have a lot of development to do there if you're going to build that.
Sorry, which thing? So would you just say about... By the way, we have a question from our live stream asking, what does wind vector data mean? And they're saying they expected to see a bearing and a speed. no, we have these are the vector coordinates of the wind. So to just for my understanding, if I wanted to turn these into a bearing and a speed, how would I do that?
We have wind direction. We have wind separated properties.
What would happen if I did that? Hopeless.
Well, you picked the wrong thing.
Oh, that doesn't help. Ah, fascinating. Doesn't give an answer. How come that arctan doesn't evaluate?
Interesting. I think it should, yeah.
Yeah, I would think so. I mean, so if I say, okay, so if that's right, and by the way, if that is right, we should document this in the wind vector data documentation, that you can just say 2 polar coordinates. So this should give the speed and the direction, correct?
Yes, but we have wind direction data and with speed data separately.
Oh, okay, fine. Okay. Fair enough. Fine. Okay, that's the answer to that. But notice that, okay, so now what you're proposing here, can I say also what the other thing that I thought was related to what we're talking about in this meeting, but I guess is not related, is my long interest in having, and maybe this is insanely unrelated, okay? My long interest in having a version of plot that can have things like a point whose position is time dependent. And being able to have some kind of rendering capability where, you know, the thing can actually render if one wants it to as an animation. Is that insanely unrelated?
What I think so, and I'm not sure that that would still then be.
Actually, what I really want is something which is more like keyframing, where I could have a point where I'm giving it, yeah, where really what I've got is a time series, right? If I say point of time series, blah, 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 that I can say something like animate point of time series and have it do the right thing. And eventually then I want graphics primitives that sort of symbolically represent, just like sound note has this capability for symbolically representing different parts of a sorry, for you know, sound note, sound symbolically represents different parts of a you know what it does. And it would be very nice to be able to do that for animated graphics primitives too. I mean, Roger, is that whose roadmap is this in, if anybody, right now?
Everything that has to do with graphics rendering has to be in the front end sooner or later. Because ultimately, I don't think that our dynamic is strong enough to do this, because I think that there's, we need to reorganize the graphics so that it can actually do it at the correct speed. But I don't want to bring it up here because I don't want to discuss it with you until I have something, because I don't want, I think that we can build nice animation languages that are very usable anyways, by then generating the videos that you want to see, for instance. Okay. And that can have all the keyframing and synchronicity and all kinds of things that you want. It won't solve everything, but it will solve, a good, interesting.
So the answer to my question is it's on your roadmap.
To reorganize the graphics is a big task.
No, I'm aware. I mean, look, we've talked about this object-based graphics, et cetera, et cetera, et cetera, et cetera, et cetera, for a really long time. And, it's a different, some aspects of this, it's a separate discussion, I think. What has happened is there any relevance to the world of system modeler and so on to all of that?
Well, I mean, System Modeler can be a source of dynamic behaviors. Now, System Modeler also has built in, when you model mechanical systems, System Modeler models way more than mechanical systems. But for 3D mechanical systems in particular, it can auto-generate animations.
Yeah.
The way that that's ultimately rendered is actually a subsystem written on top of something called Open Scene Graph, which is the thing that gives you the ability to move just the right points and not try to rediscover where there might be dynamics and what's tickleable and what's not. And,
right.
you know, got all that. And
Right.
then you can get the correct speed. That's what they were designed.
Yeah, I mean, in principle, one could think about taking the existing symbolic graphics language and through a compilation step and a dependency analysis, figuring out what has to be considered tickleable, et cetera, et cetera, et cetera.
Yes. Yes, but I think that as a user, you know, as a developer and or user of it, you want to be able to plug in at the right point and have that change, and not there be of an undetermined complexity process in between, which is what slows things down.
Sure, I agree. I mean, it depends. Look, the dependency tracking, if the dependency tracking is good enough, then you can just think at the symbolic level and just put things in that are dependent in various ways, and the dependency tracking will just take care of it.
Yeah.
And hopefully it's possible for us to do that. But okay, fair enough. By the way, I think it was the system modeler dependency that caused us to want to have multi in this meeting. And I think if we're not going to discuss that here, multi could probably leave unless there's another reason for him to be relevant to this. Anybody know?
I'll listen then. It's
okay.
Interesting.
Fair enough. Okay, terrific. Someone from the live stream is pointing out that this would be a more realistic syntax for, yes, that is correct. That's a more realistic syntax for what I was talking about before. That's an interesting form, that T, time series.
Really what you want is P, you know, because that needs to be the points, the coordinates. You know, P doesn't take times, right? It takes points.
What do you mean? I'm sorry, I didn't understand. Oh, this thing here.
Yeah.
Yes, well, it depends. If the time series has points in it, then you could imagine this working. Right. In other words, this isn't quite right. I agree, this is not quite right.
You could have point of x of t in the first argument.
Yes, but then how does it know how the binding to the time series works?
It won't. So you need those.
No, this isn't right. The T, look, the fact that this is called T is confusing. This should be P is a time series.
Yeah.
Right? Just like we say, you know, P is a region or something. Yeah, that's interesting. I agree, that's interesting.
So what is that time series of 3? Is that a XY pair?
No, I'm saying that what's in here is a time series that has the form, you know, let's say 0, 1, 2, 0.3 seconds. Oops, 0.3 second. I'm getting the braces wrong.
Yeah, that's fine.
So right. So you get what I'm saying. So that's like 0.3 seconds. You know,
right, but so the values of the time series are XY pairs.
That is correct. Yes. Right. And so what that's doing is it's feeding what that would be doing. I mean, right now, animate rather boringly just has, you know, umin, umax, du there, right? Here it's taking on discrete values, but this is saying have it over the course of time scan through a time series. That's interesting. I mean, that would be a good way to do it. I mean, I'm not sure that quite is as good as, I mean, well, I think this gets into the question. I mean, that's interesting. I'm going to keep a note of that. All right, but I don't know whether that's relevant to what we're, well, it is sort of relevant. Let's go back again to the question of the geo field, okay? So the issue is we want a thing like time series that represents a position, might be a geo position, might be some other kind of position. What would it be called? Is there a name for this in the spatial statistics business? I mean, time series doesn't really have anything to do with time, except that we recognize, I mean, in other words, if we gave, like in this case, there's really nothing about time in these first coordinates.
I think, no, not really, you know, but that's the most common case. And it has behaviors, for many of the filters and so on, they're what's called causal. They depend on history and not on the future, that kind of thing.
Right, but in what sense is time series really like an interpolating function, like a general, you know, parameter goes to value one-dimensional interpolating function?
I mean, it uses that. That's just one piece of it. That's just purely for evaluation purposes. But all the operations that we provide for you to be able to transform them in rich ways are things that is not the interpolating function, and that's the bulk of it. So it's interpolating. It's not a.
Are people hijacking time series and using it for things that have nothing to do with time? Or do they not think of doing that?
You can.
We tried this for some thermodynamics things. It didn't really work.
Why not?
Don't remember the details.
I mean, you can. If it's something that's time-like, it should work. If it's not time-like, you know, there's basically a one real notion of time. It's the real line. It doesn't have.
Yeah, I understand. So thermodynamic data would be an example of something where there is something to interpolate, right?
Right.
Whether this is some. How does this relate to anything? I mean, that's just saying there are discrete values. You know, the phase diagram for water or something is. Well, I think that one has some various functional forms, but in general, one could imagine. Okay, so let's again, let's loop back to what we're talking about here. So interpolating function, is it obvious that interpolating function squared shouldn't just work?
I mean, once you have, I was going to say this earlier, once you have applied a function to it, there's nothing the system will ever do on its own. So if this would evaluate to something, that's the only sensible thing that could work. It's not clear what exactly it would do if you square it. Just does it square the dependent, the independent, what happens if you have derivatives? But square root of this is a dead object.
What do you mean by dead? I mean, in other words,
there's nothing you can do with it. No built-in function will ever do something with it. Also, you remove the square root again.
Well, wait a minute. What about this case? This case works. You can square it and you can take the square root if you wanted to.
Yes, but you cannot do this with interpolating function. That's my point.
No, but not at this time. But what if we allowed the possibility of saying an operation on an interpolating function is taken to be an operation on its dependent variables?
That was my point. Like, on the one side, this is true, but then what about you have specified the derivative? So you also square the derivative?
No, that's nuts.
Like, whom do you square?
Yeah, no, I understand. So the problem is, if the interpolating function contains, but I mean, the same would be true if you just had the things in a list, right? You'd be saying the first element I want to square, the second element I want to take 2 times it because it's a derivative or something. And your point is, how would we specify that? But that's going to come up whether or not we call this interpolating function, whether we call it geofield or anything else. Well, maybe it isn't going to come up in that case because you're assuming, no, it is going to come up. Let's take the wind, direction, and bearing. Right? You're going to want to do different things if you apply an operation to those. You're going to want to do different things for the speed and the speed and bearing. making sense?
I think interpolating function is modeled after function itself, and we don't have arithmetics for functions.
Yeah, function is a dead object pretty much. I mean,
the same argument applies here. Function could also do something in principle.
Yeah, I think function could do all kinds of things, but it doesn't. It's dead.
Right. Yeah.
It's just a container.
Right. The one thing that goes inside, so derivative is a strange creature that eats functions, right?
Right.
Yes.
Yes, because it can take one, but if you want to do something with two functions, like adding two pure functions.
Yeah, we made the decision to not do that.
Right.
I mean, and frankly, the things like through that do that have been of distinctly minority interest for the last 3 decades.
Mm-hmm.
Well, I don't know. You end up using it. Like I always want vector rules, and we don't have it. I use through all the time.
What is vector rules? What would that be?
You know, I give for the components, but I want it among the lists. So I give it between lists, but I want it, rule doesn't recognize vector arguments properly. So you need to do it on all the elements in the list.
So, sorry, are you thinking about thread?
Oh, yes, thread.
Not through.
Yeah, through is rare. I agree.
Yes, thread is well used. Through is extremely minority. Through is ahead. Through is a neurosurgeon of the functional programming world.
Also, it is kind of like the only way to write things in modern mathematics. Yeah, like you have two functions f and g functions in the mathematical sense, and you have f plus g and apply it to x. Yeah,
true. And this is what we would have to do with if we had operators.
Yeah. No, I know. I mean, through was intended, look, 30 years ago, through was intended to be something of significance because we thought things like this operator, this kind of abstraction to operators would be common. It's turned out it's still not common. I think one day it will be, and we'll be happy we have this function. Hopefully it's designed correctly. Okay, but in any case, the point here, we have a question from the live stream. Would a squared interpolating function with linear interpolation be linear again or second order interpolation? Yeah.
See, those are all questions that come up, and if you do something that's not even polynomial, right? The square root or the sinusoid or something like that, and you're out of luck.
Yes. Okay.
But in some sense, the same argument applies to time series.
Yeah, I just said that before.
Okay. Right.
Okay. So the issue is, okay, so one question is, there may be some specialization. If we are talking about geo only, so let's imagine we're talking about a geo value field, okay, just for the sake of having a name that we're talking about, right? The argument of geo value field would be, presumably, some kind of thing that would geo value field be like geo elevation data, where it returns a quantity array. What does geo elevation data returns?
No, but geo value field will be a container. It will be something that is returned by other functions, in particular geo elevation data. It could return a geo value field that eats geopositions and returns their corresponding elevations.
Right. So fundamentally, this would be something like something with the form geoposition arrow. I want to save this. Sorry, I'm just
But the reason that this is going to be, what you're going to want is all these things. Find me the nearest points to this. Find me and modify in this region only. Do a moving map across the field to do this kind of filter operation. There's a large number of things that you want to have happen on it. And that's what's expensive, not the building the container. It's all the operations. It's like piecewise. Looks like just piecewise. But we have 100 different solvers in the system that makes that just work.
Sure. Okay, so hold on.
That's where all the work is.
Right. But so what you're saying is that we potentially have, I mean, what this thing would natively eat is geoposition value things like this, right?
Yes, it's effectively what we put in the first argument of the GeoVis functions.
Okay, so geo-region value plot.
Mm-hmm.
By the way, notice that with the statement you just made, those could be extended georegions on the left-hand side.
Exactly.
Okay, so this is...
Can they be curves too?
Theoretically, I don't know that I don't remember what it does with curves. But like geo-region value plot most definitely works with single point geopositions.
How do we represent it? Sorry, how do we represent a custom region, custom georegion? Can we do that with a region formalism?
We can add a polygon with geopositions.
Oh, I see what you're saying. So it would then be a polygon of those geopositions.
Right.
Can it be a region defined by, how do you get, okay, naive question. How do I get a region out of a polygon?
It is a region.
So regular polygon.
As long as the arguments are not geopositions.
Yeah, but those are not graphics primitives. They're not.
So if I do this and I say area, I'll get the area of a pentagon.
You also can't do graphics of a polygon with geopositions, can you?
No. I'm just saying it's still a polygon. The head of it is still polygon.
Well, but you guys did that, you know.
Which, I mean, if I say, look, if I say something like,
I think it works as a courtesy somehow. As a simple polygon of geoposition.
Okay, let's try this.
But it's not by design because it will be wrong.
Okay, so hold on. Let's say geoposition of these, right? And then, why is this taking forever? Come on, what's it doing? Oh my gosh. Okay, lovely. And now if I say geographics of polygon of that. Okay.
Mm-hmm.
So what's wrong with this?
Nothing. I think the discussion is what is, where the is in triple quote, a polygon. The meaning of polygon in region world is totally different than the meaning from polygon here.
Yes, totally
What,
different.
you mean geodetically, or what? What do you mean?
It means that geographics does a pre-processing to actually remove the geoposition there and pass a clean polygon to
I
graphics.
thought Finland was in Scandinavia as well. Am I wrong? Sorry, that's just a general knowledge question. Roger would probably know.
Finland
so
is
too.
not. No, Finland is not included in Scandinavia.
Oh, really? Oh, Nordic countries includes Finland, but Scandinavia
Yes.
does not. Right.
Okay, thank you. Okay, in any case, sorry, returning to this. So what do you mean, the question of what a polygon is, you're talking about the, curved space or what?
No. It's much more in a sense that you can programmatically check in the language. Like you can for a region queue around and check if something is a region, but a polygon with geoposition is not a region. So one could argue it's not a polygon.
Right,
Why
like
the
that
hell is it a
area
polygon?
computation wouldn't.
Well, so if I say geo area of polygon of %22, it's fine.
Right, but area without the geo.
Won't work.
Right.
That's a rather in unpleasant error message for that case, by the way. I think it should say something more specific to geo. Brett, that's, I think, who's that for? Is that for the regions people, geometry people?
Yes.
Okay, small suggestion.
Or the geo people, since they're
What is wrong with it?
It's just
I don't know.
an unpleasant message. I mean, it should say it's a geo, that you've got to use geo functions to deal with geo areas. It would be much more useful to say use geo area here, which we perfectly well know you need. So who could deal with that? Is that something that has to be some kind of upvalued thing, or is that a I mean, that's really the area function that has to notice that.
Well, I mean, but I don't know that area does know that. I
Yes,
mean, to
it
some
does.
extent, area is probably just checking,
It does. It does.
criteria for, is this a valid region?
Okay. But then, well, look, okay, somebody can look at that code path. And in the valid, is it a valid region? Does geo stuff give you things which are regions or not?
No.
So
Sorry, I didn't hear that. You said no or yes?
No, it doesn't.
No. Okay, fine. So in that case, it can error out at the region generating stage. Yeah, anyway, that's not our subject here. Our subject here, although, is there somebody from project management in this meeting? Yes, Sushma is here. Perhaps
Yes, I'm here.
can you note that and try and get something done with that?
Yeah. Okay.
Thanks. Okay. So let's see. So we're going back here to the question of can we define a geo value field? It's kind of unfortunate. Geo region value plot. What are the analogs of geo region value plot? Yeah, okay. Okay, fine. So this is a geo value field, and that would be its basic, that the way it's given inputs is this. Now, presumably there could also be a function that says, you know, somebody solved a PDE. So what happens if somebody solves a PDE over a geo region? What happens right now with that? Do we have a way to deal with that?
You cannot even write it down.
No. You have to convert it to an actual region.
Okay. So walk me through.
I mean, Geo evolved as sort of a graphics hack, and it's sort of steadily climbing itself out of that.
Well, good for it. I mean, but it's very complicated because it's got geoids and all
I know, Stephen. I know, but I'm just saying, and they happen in parallel, these things. So,
right. Although to be fair to Geo, it's really got two different branches. It's got the graphics part and it's got the geodesy part.
yes.
Which has but so okay, so let's walk through this for a minute.
But even the interpolating function, it could be, you know, very aware of, you know, if you have a, you know, to interpolate correctly on a geoid, so to speak, you know,
Yes.
it could know about all the things it needs to know about. We even
What do you mean? An actual interpolation, the function. Or
Yeah.
something else.
Yeah, because we know what projections you're using. We
so
know what Jacobians, we know compensations for transformations and whatnot.
Okay, so wait a minute. So just to what you're saying is that interpolation right now could take, if I do an interpolation, okay, so first question, if I do an interpolation that involves times, does it work in any useful way?
No.
Okay. Should it?
I don't think so, because it's going to have a whole world of syntax and notations and special cases and
Because what? Of time? But I mean, if I were to do
times and dates, because there are calendars, there are holidays, there are all kinds of things that you.
I see what you're saying. So interpolation of the pure real function of dates is not, you claim, all that useful. In other words, there is a notion of a base space, so to speak, here that is purely the time axis. You know, the one-dimensional real number time axis.
Oh, sure, that's straightforward. But you know, if it's going to be a user convenient kind of function, you need all that.
Okay, so your point is that interpolation of essentially real time, variable mapping to continuous value is not the case that you're interested in. You're interested in things like, you know, in what am I saying? In kind of well, what would be the case? Interpolation ignoring weekends or something.
Yeah,
is that the type of thing you're talking about?
Yes.
Yeah. How does this price change ignoring weekends because it's not traded then?
Right.
So how do we represent things like that? How should we represent things like that?
But isn't that time series precisely?
Well, time series has, but it's a substantial subsystem that deals with time.
Well, does time series deal with weekends?
Yeah, it deals with calendars.
How?
They're not business days. They you know, so for instance, if you have stock data, okay, weekends are counted as if they don't exist. Do you know what I'm saying? Because otherwise you would get gaps in your data. Your price, there would be missing data every weekend.
No, I understand. I understand. So you get the derivative wrong. If you go across, assuming it wasn't traded at weekends, and you're computing the derivative of the stock price, you're saying that that derivative needs to know that the delta y by delta x, the delta x is only 1 between Friday and Monday rather than being 3. Is that correct?
Yes. Yes. So therefore they want business calendars, from, when you do those.
Right. But so how do we do that in the case of time series? So do we have a calendar? Do we have that notion in time series?
Yeah, it has calendar type and holiday calendar options.
For that very reason. But that's not a small subsystem.
No.
Substantial drag on that whole.
Okay,
I mean, it's also useful.
You've given me a really good argument for why we want a geo value field, but we don't want a general vector field. For general vector fields that are really a mapping of reals to reals, use interpolating function. Does that make sense?
Yes.
But that if we want to do this geo value field, okay, let's go back to our aeroplane. Okay, so the aeroplane is actually not a geo value field. The aeroplane is on a particular trajectory, and we are merely trying to record for that trajectory, right? We are merely trying to record like the plane. If there's wind, right, the plane's nose will not be pointed in the direction the plane is going in, for example. Am I making sense? No, I don't think that's not actually what. Now I'm totally confused. I should remember this from flying small airplanes. But the heading of a plane, right? When you plot it out, the heading is the actual direction you're going, not the direction of the nose of the plane is. No, now I'm totally confused because the compass in the plane must be showing the direction the plane's nose is pointed, not the vector, not the velocity vector. Okay, I'm slightly confused there. But there clearly is a separate notion of, well, walk me through what those notions would be. I mean, things like, okay.
The one that we are currently most care about, what's the instantaneous velocity as magnitude, and what's the current change of height? These are the two things we have as actual data.
Okay, by instantaneous velocity, you mean the vector? No,
the magnitude we only have.
Do you have it as airspeed? Because that's not the same as the speed relative to ground.
I don't know.
I mean, there's two things, ground speed and airspeed.
I don't know. But okay, I know we only have the magnitude. We don't have the direction.
But we do separately have, we have the sequence of points that the plane went.
We could derive an approximate direction.
Right.
But that's a different story.
Okay, and we have rate of climb.
Yes, exactly.
I'm sure both of those are based on ground. I'm sure in modern times, I mean, in the past they were air speeds, but probably I'm sure now they're ground speeds. Okay. So what's your point there? So for every position we have, so for each thing.
Not for every position. For a finite set of times, we have positions with other things.
Okay, so we have a timestamp, we have the position, we have the velocity, we have random stuff like the climb rate, right?
Right.
Okay.
And the typical question we probably want to do is not with respect to geoposition, because we don't know where it will be on its one-dimensional path, but with respect to time.
So why isn't this just a time series with geoposition payloads?
I think because if we have a function dedicated to this, it will be able to handle geo arguments and geo properties.
Because we want to drop it conveniently into geographics and friends.
But so why would we not? Okay, so the problem is that, we've got date list plot, okay, which eats time series. right? What you're saying is we don't have a geodate list plot, in a sense.
Not even sure what it would do.
Well, okay, so I'm not sure either, but I mean, well, here's what it might do. It might draw a picture like the Napoleon's army picture or something, where it is, where it got to at a certain time with a
like a parametric plot, effectively.
Yes.
I mean, I think GeoListPlot will do that on time series of geodata.
Okay, so wait a minute. You're saying GeoListPlot. What are you claiming? You're claiming. How do I get a time series of geodata?
Okay, time series, and we'll just build up a simple example. Okay.
Let's do now, and then now plus. Let's do now. We're in LA, and okay, and
we'll
then
see if it works with entities. But
I'm sure it doesn't.
Now plus 2 weeks.
What would it do with entities?
GeoListPlot, may convert it. Okay, so then you're in, New York.
Okay, that's probably good enough for us for right now. Okay, so let's go GeoListPlot of that.
So you don't get the curve by default, but it has gone in and pulled out the values.
Okay, now what happens? But on the other, and it also doesn't in any way label the times.
Right.
Can you try geographics of Geo Path of that time series? I don't remember whether this will.
Okay. Why is that GeoPath straight in that projection? Is that just the projection in which it is straight?
Yes, change the projection to Mercator, for example.
Why did it start labeling the states?
We have labels for Equirectangular and Mercator and remove them for the other projections because they get too curved and it looks bad.
By the way, what has happened to the defuzzing of GeoGraphics project?
We are getting closer to that by using inset instead of texture, and then the objective is to have the labels separately generated.
Yeah, right.
Not baked on the tiles.
By the way, somebody is saying from the live stream, I was right that the compass direction in a plane is the direction that your nose is pointed in, which is not necessarily the vector, the velocity vector. But I think what we are getting, so do we get heading as in which direction the nose is pointed, or don't we get that in the feed?
No, we don't.
I thought we did. I mean, let's see. Let's try a random flight. No, that's not very useful. Let's try. Okay. What the heck is heading? What is heading here? Is that deduced from the interpolated points?
I do not know offhand.
I'm really quite certain that these mode C transponder things, give altitude. Don't know about this other stuff here.
Yes, altitude we have. Yes, that's correct.
Right, but okay, so this ground speed looks like it has enough detail in it that it isn't coming from finite differences. Okay,
No, that was not my statement. So the altitude I consider to be part of current geoposition already because.
Okay, fine.
But we get independently, we get dc by dt as a own field.
Okay. Okay, and this heading is a bit of a mystery.
Yeah, I don't know right now.
I'm guessing that this is absolute heading, which, by the way, probably should indicate here. That's a question for the Wolfram Alpha team, because that's a little bit confusing given okay, depending on what it actually is. All right, okay, let's go back to this. So your point here is that we could imagine a geodate list plot. So we've really got two cases here. We've got the geo value field. I'm now totally confused. What's the difference in that and geohistogram? From the point of view of
Geohistogram and geosmooth histogram, what they effectively do is to derive a value field, and by default, that's the intensity field, the number of events per area.
I see. So, but this is deriving a value field from actual given values, not from histogramming.
Right. Yeah. So point data can, it's like statistical point data can be related to fields. So I was just giving you one such example, and they can interact the other way around too. Fields can affect distributions.
Right. But okay. But so right now, we don't have. Let's see. We don't have we have geohistogram, but we don't have the smoothed field thing.
We do in SF 11.3.
We don't have the density plot.
What is it called?
Geosmooth histogram.
No, but that's still a histogram.
Right. We don't have geodensity plot.
Right. And we were just planning out that those are things that we would like to do next.
Okay, but so what this is asking for is something that goes underneath geodensity plot, because it is to geodensity plot as interpolation is to density plot.
Kind of. Yes.
Or to list density plot rather.
Mm-hmm. Yes.
Although this is really geolist density plot, isn't it? Not geodensity plot.
Right.
Right. I mean, for the most part, we've been letting geo imply list sorts of things.
Okay.
Right. Because I don't think we're going to have very many geo visualization functions that are actually taking a function.
Well, unless we manage to get PDEs over the geoid.
Right.
And Roger, can you comment on that?
No, not at this.
I mean, like, for example, we could imagine something about, for epidemiology, it would be really nice to have PDEs directly over geo coordinates.
But it would still be a discrete thing, right? A discrete representation.
Why? No, it wouldn't. It will be no more discrete than an interpolating function is discrete. It will be saying this, the probability of, it happens to be giving probability, but let's say the density, let me give you an example. Let's imagine when Mount St. Helens blew up, right? There was a big plume of gunk that stretched across the US, right? That plume of gunk was governed presumably roughly by PDE. We can imagine solving that PDE and asking the question, what is the instantaneous concentration of gunk in Chicago at day such and such based on Mount St. Helens?
Yes, but if we return a geo-value field, it doesn't matter where it came from. It's geo-value field, and internally it has a discrete, like interpolating function representation of the data.
Fine.
I mean, geo-value field could be both the constructor and the container.
Yes, but I mean, I guess what you're saying is that internally to geo-value field, you could imagine some situation in which this thing was an interpolating function. Is that right? Because that's what you would get out if you actually solved the the PDEs for Mount St. Helens or whatever. You would get an interpolating function, not a bunch of discrete values.
Yes, and if this is in some projection that handles both X, Y, and Z, that's perfectly reasonable. But the value field,
the interpolating function then would be something that is mapping geopositions to values. Is that correct? In much the same way as geo-value field does, but this is just a wrapper that says make it a smooth interpolation. That basically
but what we proposed is that wouldn't be interpolating. It would be a new object that actually understands something geo. So from a user point of view, it wouldn't be. It would.
Right, but what I'm saying is if you needed to do the loop, the workflow in which you go through the PDE functions, how do you do that?
But I think it's fine if we put inside an interpolating function. From the outside, it looks like a geo-value field. We don't care what it has inside, as long as it fits. It eats geopositions and returns values.
Okay, I see what you guys are saying. I think what you'd want to do is to put wrappers before and after.
Right. Yeah, it has to look like all geo.
I see. Okay, so I see what you're saying.
Yeah, so there's a geoposition inside this thing.
And
Okay.
and it could have, I mean, coordinates which are in some projection or some map projections, and then we don't even need geopositions. But the geo value field would worry about all of that.
Right.
Interpolating function wouldn't care about what the meaning of its coordinates.
Okay,
Right.
so geo value field seems like a sensible thing, and that would allow us to, I mean, that's solving a completely different problem from the airplane problem.
Yes, the problem with the aeroplane problem is the embedding of a line in three-dimensional space. And of course, we could be very mathematical here and prepare this for embeddings, but that's going to be very difficult. So that's why I prefer to have a dedicated geotrajectory.
Okay, how does this relate to travel directions? Don't we already have something very much like this? I mean, if I say travel directions,
travel directions can return a Geo Path, or
let's say travel directions. How does it work from New York City to Boston? Let's say.
Mm-hmm.
Okay, so now if I say geographics, if I say geolist plot of that, oh, that's weird.
No.
Why doesn't that work?
I think do geographics of GeoPath of that.
I think that thing I just did should work. I don't see why it shouldn't work. Geolist plot of that.
Well, it has very, very many points. So this is more like a line rather than point based.
Okay, but so this is exactly, so for example, one thing we're not doing here is marking the times, when do I get to Bridgeport?
Right.
For example.
Yeah.
So that would be an example of a place where, just like the plane case or the case, I mean, we need a way to show essentially a geodate list plot in which we have a line, but the line has been parameterized. I mean, look, we could go it either way around, but clearly on a map, yeah, I mean, geodate list plot is what we're going to need for this.
So can you change GeoPath to point inside geographics?
Just the word point?
Yes.
Okay, so those are the points.
Those are the points. There are very many.
So what's your point, so to speak?
Well, the geolist plot typically plots a few points of main locations or something like that.
Well, I think that's, come on, it'd be like saying list plots only a few points. I mean, we should be able to scale up the number of points.
Sure, I'm not talking about speed. I'm talking about the main purpose of the function.
Well, I don't see, you're saying, I don't see why there's a problem in it plotting more points.
Fine, okay.
But I mean, but your point here is, I mean, clearly this is sort of the inverse of, well, these points have no relationship to when you will reach, Hartford, for example.
Right.
Mm-hmm. Right. It's not like they're every 5 minutes or anything.
No,
right.
Not at all.
But so the correct visualization for that is you have a line and you have essentially mesh points on that line that represent the times, I think. Or maybe you have a little tick mark across.
Mm-hmm.
I mean, that seems like one useful visualization. Another visualization is you might show the vector direction of the direction that nose of the plane is pointing at every position there, which isn't just, tangent to the trajectory.
But these points are there for every single change of direction. And if you do this with dynamic geographics and zoom in, I think it will become clearer.
So you're saying dynamic
geographics. And now zoom in to some points.
Why doesn't this let me help? Why is it not? That's a bug.
That is a bug. Why is that not? Okay.
I mean, this is 11.3 prototype build, so I have no idea what it is.
I'll take a look at it after the meeting.
Okay, so when I'm going around that corner there,
Exactly.
I've got a bunch of extra points.
Exactly.
So those points are at that road is represented in OSM as a bunch of line segments. Is that right?
Yes. So this is approximating that data. Yeah.
Okay. Okay. So that's one thing. That's, in a sense, if we did a geodate list plot. I mean, it's really a geo time plot of some kind.
I mean, I think it's the analog, the geo analog of a parametric plot, seems to me. And you might want to highlight some things, label some things.
How do you, in a parametric plot, how do you, so you're using mesh. Go ahead.
Well, we don't have labeling there at this point, but you can certainly, yes, you can certainly show the mesh that you've been using.
Right. Every 5 minutes or whatever else it is. Right.
Right.
Which would be a good start here. It will be even better if you could mark, 3 p.m., 4:30 p.m., and so on.
You need to know your start time some way.
Well, if you have yes, right. But, or you need to just have relative times, 1 hour, 1.5 hours, etc.
Right.
All right, let's zoom out, and we have to wrap up here. So what we're concluding is, I mean, this meeting went in a very different direction than I expected. It sounds to me like geo value field is something that is in our path, so to speak.
Yes, it is.
Don't we also need? So I'm a little bit confused. If we have a geo path, don't we need the analog of geo value field for telling us at this parameterized time, you will be at this point on the geo path? Right. In other words, if I say, where was that plane
Right.
at 11:17 p.m.?
That's kind of one of the main things we need from this function. Yeah.
Yes. So I suggest a geo trajectory for that, not having GeoPath being responsible for doing that.
No, I understand. But I mean, what you're saying is, what you are then implying is the geo trajectory, which is where, okay, so you're saying there's a geo trajectory which has various different attributes. It has the times, the positions. It may or may not have extra annotations like the velocities.
It's good, yeah, exactly.
Okay, and you're suggesting, however this is set up, that there's an accessor here that allows you to ask for an absolute time,
right,
and get out a result.
Exactly.
And also that geotrajectory, when displayed in a geographics, would display in some way that marks its time points.
Exactly. It would be an implied geopath with some additional information that we might show.
So let me give you an example of an issue there. Isn't there an issue of essentially a plot range for the geotrajectory then? Show me only where the geotrajectory went on Saturday. Right, so we're going to want to have, or we're going to have a slicing function, a windowing function.
But
show me only the Saturday part.
Well, but I think this, from the point of view of graphics, this represents a geopath. So this would be treated in terms of plot range as the geopath. And then if we want less than that.
Right, but the plot range is in the geo space as opposed to in the time space, so to speak.
Exactly.
So I think we would.
But if you have just a Saturday, geotrajectory of a time range could evaluate to a geotrajectory.
Good point.
Exactly.
Good point. So this would be a date interval here, and that would be the solution to that problem.
Yeah.
Okay. So I think this makes a lot of sense. This function, geotrajectory. Now, what would its detailed arguments be? Would it be essentially, I mean, ultimately it's got to be, I mean, it could be purely geopositions with, I mean, I think that's a little bit grotesque with X, Y, Z, T. That would be one way to do it. But presumably we have to support a different form as well, which is more of the form T arrow geoposition.
Does geoposition have time in it?
It does.
Yeah, fourth argument.
Really?
Yeah. Yeah. I mean, that we were just showing that at the beginning of the meeting. If we say, what's the geoposition of the International Space Station? It contains the time.
Well, the name doesn't give any hint of that.
You don't say. Right.
Well, I mean, because the datums also have time references associated with them.
Yeah, that's a datum. That's, you know, like nobody knows what datum is unless you know what it is. I mean, it's known well by the people that knows it well, so to speak.
Yes.
It's well known by people that knows it well. That's what I meant.
I must say that I didn't add this. It was there from the beginning in version 7. This time thing.
Yes, I think we needed it, right, for the datum stuff. We needed it for correct geodesy. Okay. Okay, so let's go back here to the geotrajectory stuff. So what we would do, so I assume that time series supports T arrow type stuff as well, does it? Or does it not? What's that?
Yes.
Okay. So I mean, we should support whatever time series supports in terms of the way to relate times to payloads.
Yeah, we can be very flexible in input, and then yeah, it will convert to a canonical form.
All right. So look, I think the answer to what does the plane give is the plane. What does the, you know, where does the plane go as the plane goes on a geotrajectory? Is that a satisfactory answer for you, Michael?
I think so. Can we a little bit discuss what the shape of XXX is? Is it just a list of values? Is it the association?
No, I was imagining that it, well, whatever time series does, this should do. So I'm just suggesting that XXX here is, which XX?
But time series has this one feature which is not so nice, that all the data have to be rectangular.
So here I would say T goes to a geoposition or a list of things. Geoposition and your vector field for the direction.
In principle, if Wolfram Language support an abstract vector space, that could work there.
Well, you're asking, can you do this with a non, I don't know how we would render that graphically. I mean, with respect to the accessor, you know, with respect to this accessor, we can certainly deal with that.
No, but then I think
obvious how we interpolate those things.
I think we misunderstand it a little bit. Like, obviously, XXX is kind of a repetition of what the first one is, but we haven't yet folded in the auxiliary information.
You mean the velocities? And
yes.
Things.
Where would it be and how?
Well, I'm imagining, but I might be wrong, that it's on the right-hand side here of the T arrow thing.
Yeah, I think so.
Together with the geoposition.
Along with the geoposition, yes. Yeah. That it could be not just a naked geoposition, but you know,
that's the kind of thing that you can do for a function like this, because you can sort of enumerate what are the things that can be there that are useful, and then it does, you know, it does very few operations, generally speaking.
Yeah, but it's completely unobvious what that's going to do. Look, if I gave two geopositions, if I go T arrow, you know, pair, geoposition, what on earth is that going to do?
Well, the first one is considered the position at which it is. The second one is arbitrary information, which could be
fine. Whatever you want to say that. I think that's a good start. I mean, I think we might get more sophisticated, and the T arrow thing might be able to be an association where we could give a preferred key, like location or something, as the actual position, and then the other stuff is other parts of the payload. I mean, I can see all kinds of issues, like, do we interpolate the other elements of that? You know, when you do an accessor at T1, do you interpolate the other elements of that payload or not? See what I'm saying?
Yes. So this certainly needs an interpolation order.
Well, it does, but it needs an interpolation order for all the different pieces, because you might want a different interpolation order for the, you know, the altitude from the geoposition. I think that's a level of complexity. I mean,
do we do that in time series?
Do we have to fill in all data? Like time series insists on.
No, I understand rectangularity. Yeah, I understand. I don't know. I mean, I think what do we have that is, I mean, this is like what would exist in like a machine learning function or some other place where we are giving, you know, where we're specifying what here? I mean, where, you know, in the machine learning functions, right, there is a not complete insistence on rectangularity. Although the things that can, you know, then there are all these net encoders and things which turn whatever data is given into some kind of canonical conforming form. Let's try to not address this issue right now. I mean, what we have to deal with right now is geotrajectories. We finally get the, you know, the voyages of Captain Cook, which I think was one of the, you know, I think it's in the data repository, that, you know, where he went at what time, you know, ending up wherever he ended up, Tahiti or wherever it was. You know, where we should be able to plot that, showing, you know, with a trajectory, showing marks, showing when we, you know, labeled. I guess what that is something we don't have yet for mesh, for, you know, mesh points in graphics, which is label the mesh point. And here we might imagine that I guess here we should be able to have a labeled. How would we do that? I don't know. We'd probably want some kind of labeled thing. I think we ran out of time here. We've got a direction here. I think this is going to work for the flight, you know, to know roughly what we return from the flight data stuff. Anything else we need to cover essentially here? Nope. Okay, good stuff. And to people on the live stream, see you later. And to everybody in the meeting, see you later.
Yep.
Bye.